gold with nitric acid, nothing happened. And so we saw gold with nitric, no reaction. We can't dissolve gold with nitric acid under standard conditions, but what can we dissolve gold in? What works to dissolve gold? Not that you would want to do it, but what could you dissolve gold in? Aqua regia. Aqua regia is what?
Sulfuric acid and nitric acid.
Close, not sulfuric though. Hydrochloric acid, right. And so if we did this, if we did gold plus nitric plus hydrochloric. Hydrochloric is what formula? HCl. That could work. Let's do this. You know, we can't do it physically. We have to dissolve gold chemically. That is, we've got to change it. You know, there's physical dissolution and chemical dissolution. This would be chemical. It's no longer going to be really gold proper, but at least you could dissolve solid gold and convert it to something else. And so let's take a look at trying to solve this problem here. There are different routes. We look at metathesis like double replacement. But double replacement is not going to happen here. So we might consider redox, or we might consider acid-base next. Probably I'd consider acid-base next, but no acid-base reactions are going to happen here. So we can consider redox. And so when redox, what's the first step in the chart method? You know, what you guys should be doing is, you know the problem we did yesterday with gold? You should repeat that by yourself. You know, closed book or closed notes, open book, but closed notes. Do you repeat it yourself? You know, the calculations, it's like this. The way I see it, the analogy is like that. You watch somebody, let's say I want to learn how to play the piano. And so I'm going to watch somebody play the piano. And then, okay, I think I got it. You know, by watching them, I think I can do it. And so the test comes. You have your piano, whatever, recital. I'm ready for it, right? Are you really ready for it? Not at all. I mean, you can't learn by watching. The only way you learn is by doing it. And so if you don't repeat the calculations, it's like watching somebody play the piano. It's not very, you know, a lot of people say, yes, it makes sense. It makes total sense. The other analogy I have for this is like, let's say you're visiting the jungle, right? And you have no idea of the path, the multiple paths that go through the jungle, right? But you have a guide. And the guide just takes you along, and you just follow the guide. The guide just knows exactly where to go, right? Which path to take, and everything like that. And so you just follow. Oh, that was easy. You know, I just followed the guide. All the paths make sense. So the next day you go out in the jungle, but you're by yourself. And now all of a sudden you see all these other paths that you didn't see before because you were just following the guide. You know, and that's the other analogy. The only way you're going to learn these things is, you know, you take the wrong path, here, then there you backtrack, etc. That's the learning process. You don't watch somebody who's been doing this, you know, for decades. It's different when you do it on your own. And so if you haven't done that, then you know. Actually, maybe you've been working on the homework. I know there are people who've been working on the homework, and on number 4, you know,
So homework on master
on Piazza. The homework's on Piazza. It's a paper assignment. It's not. This stuff is not in the book. It is in the book, but it's all mixed up. So you made a paper assignment. And so, you know, you try the same thing on the homework. Not all the problems are the same. They're not all metathesis problems. So sometimes we look at this problem and we go, you know, how should I approach this? It could be metathesis. We look for ion combinations, but the only ions we have are hydrogen ions, nitrate ions, and chloride ions. There's no good ion combination. And so we go to we try redox. Let's try redox. And obviously, single replacement. Is single replacement going to work? No. It failed for nitric. It's going to fail for HCl. The chart method, it didn't work for nitric, but let's try the chart method here. What's the first step in the chart method? Inventory. And so gold, H+, nitrate, chloride, and what else? Water. And then we look at our chart. Gold occurs on the lithium side, so that's a reducing agent. H plus occurs on the fluorine side, that's an oxidizing agent. Nitrate and H plus occurs, we did this earlier, occurs on the fluorine side, that's an oxidizing agent. Where does chloride occur? Chloride occurs on the lithium side or the fluorine side? Well, chloride occurs on the lithium side. And so that's a reducing agent. But chloride doesn't just occur here. I see chloride here. But I think I saw chloride before. Did you see chloride before? I think we saw chloride before, didn't we? On this chart. That's because, you know, I looked at the chart in more depth before. Did we see chloride before? Yeah, I saw chloride before. Remember this? Chloride and gold. So we have that. We have chloride and gold this time. So chloride and gold. Chloride and gold, this would be a reducing agent. It's on the on this side. And you know, I've actually looked through this whole table. I've seen chloride again before. Let's see. Chloride here. Yeah. Yeah, I did see chloride before. So I kind of remember it. You know, here it is. Chloride and water. Do we have water? Yeah, we do. We have chloride and water. Chloride and water, that's going to be a reducing agent or oxidizing agent? It's going to be a reducing agent. This chart having the fluorines on the left, the lithiums on the right. The chloride and water, were there any others? Oh, wait, there is a gold here. Am I missing this gold? Did I accidentally miss this gold? You can read this here. This is AU3 plus here. This is AU plus. Did I miss this gold? Shouldn't I add that over here? I see both yeses and nos out there, and the correct answer is no, because is gold solid the same thing as AU3 plus? Is gold solid the same thing as AU plus? Do we have any AU plus or any AU3 plus on? No. And so we can't, we don't have any of this, so we just ignore it here. The people, the people, you got to watch out because, people think, AU solid and AU3 plus are the same thing. I don't know how many times I've seen that on tests. People will write, I tell them we have silver plus, they give me silver metal. How do you get silver metal from silver plus? Silver plus is an oxidizer. It stains your fingers black. So does silver metal do that when you put on silver jewelry or something like that? Is it going to stain? No. It's totally different stuff. And so somehow they magically got silver metal. That's what the alchemists wanted to do. You know, they wanted to transmutate. They wanted to magically form gold, right, from other elements like lead. But anyway, that's about it. And so I think we have it covered. We can go through the whole thing, take a look carefully. Except for water. Water is going to be what? Yeah. Both. There are other species that are like this too. You know, do you know any of them? Did anybody look at the chart? Anybody look at the chart on the PowerPoint, or nobody? At least read through the entries and then see that there are others like water occur on both sides. No? Okay. Well, eventually you should do that, but the problem is people do that right before the test and it doesn't stick in their memory. And they don't have time to think about it to make any kind of connections with that. Anyway, we'd approach this exact same way. We'd look for the strongest. So it's hard to read the chart. So I'll just tell you, as we go from fluorine down, we're looking for the strongest oxidizer. And the strongest oxidizer is going to be the same as before, nitrate and H+. It didn't change. However, when we go on lithium, we go from lithium and then we work our way up. Since this is a multi-page table, I'm not going to go through it. You just do it. But as we go from lithium and we work our way up, it turns out that the strongest reducer is chloride and gold. Now, why is chloride and gold the strongest reducer? You know, last time we were looking at, you know, water being stronger. The reason is because of the chloride. What does the chloride do? The chloride, the chloride is important. If we didn't have the 4 chlorides in here, it's not going to happen. What's so important about the chloride here? You know, this is like 1 cup of sugar, 4 cups of flour. If we don't have the 4 cups of flour, this is not going to happen because the chloride does something. What does the chloride do? The chloride stabilizes the gold 3 ion. Actually, this turns out to be a gold 3 with 4 chlorides attached to it. This species here has a name. This species, AuCl4 minus, let me just talk, this is just an aside here. AuCl4 minus, you could think of this as being a gold 3 plus, but normally when we have a gold 3 plus, we want 3 chlorides, right? We form gold 3 chloride, like an ionic compound. But this is a little different because what happens is 4 chlorides attached to it. And the bonding here is unusual because the bonding turns out to be quite covalent, and it forms a molecular compound like this, in which these chlorides are actually covalently bound to the gold. And so it looks like this. It actually forms what we call square planar structure. Here. This is why gold 3. Remember, gold 3 is a bit unusual because we kind of figured it should have been not gold 3. It should have been gold what? Charge. What charge? This should be automatic. Why should this be automatic? Because it should be automatic because the way and the way maybe you remember I told you I had to revamp the way I study? I used to study by cramming everything right before the test. Right before the finals when I go back and review everything, but that turned out to be a huge mistake. What turned out to be much better is to start studying for the final every day. And so let's say I talked about this gold 3 thing. I mean, well, not gold 3, but I talked about gold 3. I talked about gold 3 what? I talked about it 2 days ago, 3 days ago. 2 days ago, yesterday? Can't remember. I talked about it earlier, right? And the way I study is I review my notes every day, especially near the beginning of the semester I'd review it. And so if I talked about it 2 days ago, I've already read it twice. if you read it twice, how much more is it stuck in your memory? And so the notes don't take long to read, right? And so you read your notes. I used to try to read my notes every day. If I reread my notes from page 1 to the end every day, it didn't take that long, and it kept everything in my memory. And so I did mention this, but most people will forget, and they'll never come back to it. Even for the final, they'll never come back to it. I told you that we don't expect gold 3. We expected gold. We didn't expect gold 3. We expected gold 1, right? We expected gold 1. Gold 1 would give us a D10 electron configuration. Gold plus 2 would give us a D9. Gold plus 3 would give us a D8. It turns out that a D8 electron configuration, having 8 d electrons, is stabilized by having a square planar structure like this, and we'll see this in chapter 24. It's called crystal field theory or ligand field theory when we get into it. But we're not going to get into it now. What we're going to just do here is this. We're just going to learn how to name these first. And so naming these are called complex ions. And complex ions, this is chapter 24. And so the way we name this particular complex ion, this is called the tetrachloroorate. All one word, orate. And then the charge on gold is 3. And so this would be called the tetrachloroorate 3 ion. And what happens is gold 3 itself, you remember gold 3, this is not stable. Au 3 plus AQ. When we see AQ, what's surrounding the gold? Water. So we have those hydrations, and then we have, what are those interactions called? The gold 3 with the water interactions are called what type of interaction? Ion dipole interactions. And so we've got those ion dipole interactions. That's not strong enough. This is totally unstable. And so the purpose of the chloride is to help stabilize it by forming this complex ion, which will, significantly, because these are covalent bonds. These aren't just ion dipole attractions. These are actual covalently bonded to help stabilize it, reduce the charge. Actually, this is not 3+, sorry. What is the charge on this? Even though I write Roman numeral 3, it's not 3+. The Roman numeral 3 tells us the oxidation state on gold. The net charge on this is -1. And so that's what we see here. Now, what happens now is, with chloride present, this becomes a much stronger reducer because it's here now, much